goals of my project is to enhance workplace safety, uses an object detection model to identify proper usage of PPEs. When a violation is detected, this notification will be sent to the supervisors so that they can intervene immediately. This can be applied at construction sites and multi-site scenarios. The biggest challenge I face is collecting the data set needed to train a highly optimized model, as we do not have a lot of construction sites that is taking place while the training process is ongoing. As such, we have to counter this issue by synthesizing data which simulates real-life scenarios. The most important learning point for me is to always keep an open mind and to embrace challenges that come your way, because this project is very dynamic and there's a lot to learn.
Our project's name is actually the automatic pour-over coffee making process. The goals and objectives of our project is to replicate the spiral motion of the traditional pour-over coffee making process by incorporating two linear rails, and they act as something like a 3D printer. Works as a coordinate system to create the spiral motion. I would say the most challenging part of our project is figure out the coordinates of each spiral point, and we overcame it by incorporating optical sensors. Through that, we can find the 0 point of each rail, and we actually managed to map out the spiral motion. We had to delegate the work properly and secure the deliverables.
We realized that within the world there's actually quite a lot of places that do not have access to clean and drinkable fresh water. Our objective here is to create something that's not only portable but also reliable and reduces the carbon footprint.
As long as there is a flow of water, so the source doesn't matter, that principle allows it to be used in any part of the world because of the fact that it's flexible in this sense. The most challenging part of this project, I would say, was the nature of this project was such that having a relatively complex circuitry was inevitable. So because of that, our team constantly had to continuously develop our fluency in configuring electronic circuits to ensure that our project was a success.
Our project is collaborated with BCA to find out the loss of granite fines in various wind conditions, encourage the use of granite fines into more future construction projects so that it is an alternative to replace the natural sand for concrete production. First of all, we will input with all the data, the dimensions, and input them into open form. From there, we can then visualize the wind tunnel and the wind speed that is happening within the tunnel and see how it will affect the sand particles. As this is a new software that has just been taught to us, and we managed to step out of our comfort zone, and we felt happy that we are able to do something contributing to our local construction industry.
We have planned to expand this electrochemical water treatment project to multiple adaptations into plants and industries, such that it can be used for industrial use. When plants need clean water, it can be recirculated on-site so that additional chemicals are not needed. We use the concept of electrolysis by charging electric current through the electrolyte solution, which in turn produces chlorine, a natural disinfectant that is able to clear out the E. coli in the contaminated water. There's no need for additional chemicals such as chlorine needed to be transported to the site itself, and thus reduces carbon footprint in the environment. So throughout our design process, the most challenging problem we faced was the fact that vendors were not able to cut our plates. And this actually halted our design process for a while because we had to change our whole model prototype and how we were to adapt to the situation. It is important to talk and communicate with our team so that each of us knows exactly what we are doing with our project.